Hello, good morning, Miss Ricky. So we are from Group 3 will present about the addition and subtraction of trigonometry. My name is Callista and
My name is Willy.
And my name is Cosine.
so without any further ado, let's get started.
So, before we begin with our lessons, let us begin with a little brain teaser to check your skill. What is the answer of cos 15 degrees minus cos 75 degrees? Starting now. Alright, the answer is 1 over root 2. Now, the formulas that my friends are going to talk about is very important, especially if you're having a math competition like an Olympiad, since it requires speed and the ability to manipulate equations like trigonometry. So, without further ado, let us begin.
Hello, Mr. Ricky. My name is Callista, and now I'm going to explain about the addition and subtraction in sinus in trigonometry. Okay, so we're going to explain about addition first. So here is the formula of addition in sinus in trigonometry. Okay, so before we continue to the formula, we should know that A is equals x plus y and B is equals x minus y, which is the x is a plus b over 2 and then the y is a minus b over 2. So how we can get the a plus b and a minus b? So here is the tutorial. So disclaimer, the alpha and beta is just for example of a, f, x, and y. So if a equals x plus y and b equals x minus y, and then we can total it, and then we can get a plus b equals 2x. And then we can move the x into the left, and then we can get x equals half in the bracket of a plus b over 2. Or can we get a plus b over 2? So the alpha and beta is x and y, yeah? And then for the second, a equals x plus y, and then b equals x minus y. And then we can subtract it, and then we can get a minus b equals 2y. And then we can move the y into the left, and we can get y equals half a minus b, or we can get a minus b over 2. Okay, so just for your reminder, alpha and beta is just example, okay? So in my PowerPoint, I wrote it in a plus b, yeah. It's x and plus y. It's the same, yeah. And then after we know about the a plus b and a minus b, we can insert it into the formula, which is the formula is sin a plus sin b equals sin x plus y plus sin x minus y. And then we just can insert in the x and y, which is sin x cos y and then cos x sin y, and then sin x cos y and cos x sin y. And then and then we can eliminate the cos x sin y because it's minus the last cos x sin y, it's minus, so it's become eliminate. So we can get 2 sin x cos y, and then the x and the y, just we can change it into a plus b over 2 and a minus b over 2. So we can get the formula of sin a plus sin b, which is 2 sin a plus b over 2 and cos a minus b over 2. Okay, now we continue to the subtraction of sinus A and sinus B. So the subtraction is not as different as the addition, but the difference is we can just eliminate the sin x cos y, not the cos x sin y. It's because the sin x cos y is negative, so it's become a 0. But the cos x sin y, it's positive, and the others cos x sin y in the end, it's positive too. So it's gonna be 1 and 1 added into 2. Cos x sin y, and then we can just insert the x and y, which is the x is a plus b over 2, and then the y is a minus b over 2. And then we can get the sin a minus sin b is 2 cos a plus b over 2, and sin a minus b over 2.
Okay, so now I will explain about addition and subtraction of cosinus. Before we get into the equation, as explained before, let a equals x plus y, b equals x minus y, x equals a plus b over 2, and y equals a minus b over 2. So let's start with the addition of cosinus. So we have here cos a plus cos b equals cos x plus y plus cos x minus y, because a equals to x plus y and b equals to x minus y. So using the formula of addition and subtraction of the angle, we will have cos x cos y minus sin x sin y plus cos x cos y and plus sin x sin y. So because there's a negative form of sin x sin y and a positive form of sin x sin y, we can eliminate them and we will have 2 cos x cos y equals to 2 cos a plus b over 2 cos a minus b over 2, because x equals to a plus b over 2 and y equals to a over a minus b over 2. Okay, so let's continue with the subtraction of cosinus. So we have here cos a minus cos b equals cos x plus y minus cos x minus y. So using the formula of addition and subtraction of the angle, we will have cos x cos y minus sin x sin y minus in the bracket of cos x cos y plus sin x sin y, because there is a bracket here and there is a minus here, so we can multiply the minus into the bracket. So we will have minus cos x cos y and minus sin x sin y. So because there is a negative form of cos x cos y and there's a positive form of cos x cos y, we can eliminate them and we will left over with minus 2 sin x sin y equals to minus 2 sin a plus b over 2 sin a minus b over 2.
Okay, now it's time for a little exercise to test your knowledge. Now let's begin with an easy one. This question. The question is, what is the answer for sin 10 degrees plus sin 80 degrees minus root 2 cos 35 degrees? Now, don't worry, this question is actually quite simple. We just need to focus on this underlined part here. By using the additional formula for sine, we can get this by substituting a with 10 degrees and b with 80 degrees. 2 sine 10 degrees plus 80 degrees divided by 2 times cos 10 degrees minus 80 degrees minus 2 minus root 2 cos 35 degrees. And then we'll get 2 times sine 45 degrees times cos minus 35 degrees minus root 2 cos 35 degrees. We know that sine 45 degrees is root 2 over 2 times, while cos minus a is equal to cos a, so cos 35 degrees minus root 2 cos 35 degrees. By eliminating both of these, we will get the answer to be 0. Now for the second question. For the second question, we need to prove for any given a that cos 3a minus cos a divided by sin a plus sin 3a will be equal to minus tangent a. Now to do this, we just need to use the subtraction of cosine formula for the numerator, where we'll get minus 2 sine 3a plus a divided by 2 sine 3a minus a divided by 2. And to use the addition of sine formula for the denominator, which is 2 times sine a plus 3a divided by 2 cos a minus 3a divided by 2. We can just eliminate both of these and we'll be left with minus sine a divided by cos minus a. Cos minus a can be equal with cos a. So we'll be left with minus sine a cos a. Since sine a divided by cos a is tangent a, we'll be left with tan a. And therefore, this is proven. Now we're going to talk about the third question. So, one of the ways we can approach this problem is by using the trigonometric identities. Now, we should know that the double angle of cosine is 2 times cos squared theta minus 1. Now, with this, we can actually find the value of the square of cosine. Now, with this, we can substitute it with the angles of A and B, but not C because of reasons that I will mention later. So, cos 2A plus 1 divided by 2 plus cos 2B plus 1 divided by 2 plus cos squared C. And then we're going to add them together. We'll get cos 2A plus cos 2B plus 2 plus cos squared C. Now, by using the addition formula, you can get the fact that the answer would be 2 times cos A plus B cos A minus B. And then we're going to put them together and we will get cos A plus B times cos A minus B plus 1 plus cos squared C. Now let's continue with the third and final question. So, in a triangle ABC with A, B, and C as its corners, we need to prove that cos squared A plus cos squared B plus cos squared C is equal to 1 minus 2 times cos A times cos B times cos C. Now, how do we solve this problem? Now we still need to solve angle C. Now, thankfully, we know that the addition of all angles in a triangle is 180 degrees. Therefore, we can change C into 180 degrees minus A plus B, as you can see right here. Now, by substituting it, cos squared C as 180 degrees minus A plus B, we can change it to cos minus cos A plus B squared. However, since it is squared, it will stay positive. So cos squared A plus B. Therefore, the answer will be cos A plus B cos A minus B plus 1 plus cos squared A plus B. Now, once we're done with this, we can collect them both by using A plus B with their, because they have the same factor. We'll get cos A minus B plus cos A plus B plus 1. And then what we can expand both of these and we'll get cos A plus B times 2 cos A cos B plus 1, which now seems to be quite familiar. Now we can also transform A plus B back to C by remembering that C is 180 minus A plus B. And the fact that anything that is 180 theta cosine will become minus of it. Therefore, we can simply change it into minus cos 180 minus a plus b times 2 cos a cos b plus 1. And then we transform it into c and we'll get 1 minus 2 cos a cos b cos c. Therefore, it is proven.